Hello, it's Scott Manley here. It's May 1st, it's time for another batch of Deep Space updates. And yes, we begin, as always, with the launches, one of which basically happened before I was even able to post the previous episode. April 16th, a Long March 4B took off from Jichuan, I think. It was carrying a weather satellite called Fengyun 3G. Now this, unlike the other Fengyuns, I think this went into a low inclination orbit because it specifically focused on observing and measuring precipitation around the world in the latitude range which it covers. On April 19th, from Florida, there was a SpaceX Falcon 9 carrying another batch of Starlink satellites for Group 6-2. These were only 21 satellites because they are the heavier V2 mini satellites. And on April 20th, we finally got the big test flight of Starship. OMG, I will talk more about this later. The reason why I wasn't at Starship along with all the other space nerds was because I was at this thing called ThinkerCon, which, yeah, I'll talk about that in a minute as well. So April 22nd, the Indian Space Agency, ISRO, they launched PSLV carrying a dual payload for Telios 2 and Lumilite 4. These are two satellites from Singapore. Telios is a synthetic aperture radar satellite that was going to do Earth observation, and Lumilite 4 is a 12U CubeSat which is supposed to monitor maritime traffic. It was built by their university. There was a whole bunch of other payloads which were flown attached to the upper stage. These are experiments like computers, star trackers, other hardware which might go on future rockets. Those weren't really they were launched with the mission, but they weren't like a part of they weren't deployed. See, this was the PSLV CA, which means core alone. It didn't have any of the strap-on boosters. And without the strap-on boosters, it's a smaller launch, less capable launch vehicle. It can only launch like 1.1 tons into low Earth orbit. On the 27th of April, there was a Falcon 9 from Vandenberg, and this was one that was supposed to launch a few days before, but kept on getting delayed due to upper level winds and weather situations. I think the weather may have been, at one point they cancelled it because the landing zone weather, the waves were too high for recovery. And this was another batch of Starlink going into a 97 degrees sun synchronous orbit, 46 satellites. And by the way, if you've ever watched NASA Spaceflight, I saw on Twitter that Thomas Burkhardt, who was a presenter with NASA Spaceflight for a long time, is now working at SpaceX at Slick 4 in Vandenberg, so he was there for that launch, so congratulations on the new job, Thomas. And the 28th of April, Falcon 9 again, and this was carrying a pair of mid-orbit communication satellites. SES launched the O3B M-Power satellites 3 and 4, so O3B is the other 3 billion. These are basically communication satellites which are supposed to provide high bandwidth internet capabilities. They're not up at geostationary orbit, they're down at like 8,000 kilometers. So they were initially launched into like a 7,000 kilometer 8-degree orbit, but they're going to use their own propulsion to lift themselves up to an 8,000 kilometer equatorial orbit. So, you know, they do things like a backhaul for cellular services, local internet connectivity, cruise ships, that kind of thing. Now, we had hoped at one point that we might have a Falcon Heavy launch within like 2 hours of this. It would have been the closest launch of two rockets from Florida ever. However, yeah, our power got off early in the launch window. The rain came in. There was lightning and tornadoes and all sorts of other insane, crazy weather there, and they could not launch. We ended up getting Falcon Heavy launching just last night, hours ago. This was going to be the most epic of Falcon Heavy flights ever, right? This was Viasat 3, and it was also carrying the Arcturus satellite for Astranus and a G-Space 1. And this was going to be a direct injection into geostationary orbit. They expended all 3 cores of the Falcon Heavy. They were basically, I think the final core reached something like 17,000 kilometers per hour before the second stage even got going. They sacrificed all 3 cores of a Falcon Heavy to the god of Delta V, and that included the Virgin core, so you know the sacrifice is really going to work. Yeah, this was a big deal. Also worth noting that if you look at the second stage, part of it was painted grey because it was going to spend like 6 hours cruising up to geostationary orbit, and they needed to keep the fuel warmer than normal, so you had to make sure that it absorbed enough solar radiation. So this is like one of the most capable communication satellites ever built. It has 30 kilowatts of solar cells to keep all those transmitters and processors running. It can handle 1 terabit per second of data. A secondary payload on this is the Arcturus for Astranus. Now, I visited Astranus last year. They actually have their facility in San Francisco, and I'm not talking like peninsula. They are like down in the dog patch near where the Warriors Stadium is. And yeah, this is a small geostationary satellite that is able to provide communications again. But they've got this whole like standard ability to make these things, build them quickly and get them launched. They're a lot smaller than the average geostationary satellites. Very cool little piece of technology. So that will serve Alaska, providing some like backhaul capabilities for local internet providers. Also on that was G-Space One, and this is another fun one. It's a CubeSat with a bunch of hosted payloads that's going to geostationary orbit, and the most important payload is called Nunsatara H1A, and it is basically an Indonesian payload which communicates on the relevant frequencies that they need to keep access to, because they've got a license to launch a larger satellite to geostationary orbit that's going to use these frequencies, but if they didn't get hardware into that slot, they risked losing it and having to reapply. So they put this little satellite up there to basically reserve their place until they got the bigger satellite out there. So anyway, rewinding, yeah, I was at ThinkerCon, which it was a sort of a secret little conference for a bunch of media creators and stuff like that. A lot of cool people there. But I think the thing I really want to tell you about is that I did get to go on a couple of field trips. One was to the Marshall Space Flight Center, where I visited one of the coolest part of that was the test stands. I mean, sure, there was 3D printing, pretty amazing. The control was okay, but the test stands where they tested hardware, where they actually destroyed chunks of, where they destroyed an SLS tank while testing it. They actually gave me a piece of tank. It's down there, you can't see it. And this was just across from Blue Origin's test stand, where they bought one of the old test stands, or they're renting one of the old test stands and refurbishing it. I would love to show you pictures, but they said no pictures. And behind that, there was the test stand where they accidentally blew up the Vulcan Centaur upper stage a few weeks ago. It actually looked in surprisingly good condition. I think it was a lot of fire, but not a lot of damage by the looks of things. But the other thing was I got to go to ULA's factory in Decatur, Alabama. And sure, a lot of the stuff, I couldn't take any photos. If you want to see inside that factory, Smarter Every Day, he has a tour where they actually go over a lot of the details. But it was very cool to be in the sort of final integration area where they had an Atlas, a Delta, and a Vulcan all on their side, pretty much ready to go. We also saw the final IPCS for SLS number 3, and we saw the final Delta cryogenic stage for the final Delta IV Heavy. There was the Centaur, which will be used for the next Starliner flight. That was packaged up, ready to go. And in the integration area, we also saw Centaurs for the Kuiper launch contract, and another double-engine Centaur, which was for the first operational launch of Starliner. All very cool, and yes, very cool rockets, but I'm going to say much cooler people, because people are greater, are cooler than rockets when it comes down to it. So yeah, I did actually get to watch the Starship launch over breakfast with a little iPad, and you saw that, and yeah, it was spectacular. I did a whole video about it. It's got a ton of views. Since that video came out, there's been some developments. Well, first of all, we found out that everyone that put cameras nearby, there were a lot of casualties. Some people managed to recover images from their cameras. Some people didn't even recover their operational cameras. That video of their car getting smashed by concrete debris, you got to understand, the cameras strapped to that car were worth a lot more than the car. But yeah, on Saturday, Elon had a little Twitter space where he revealed some more updates on what had happened. This was a Twitter space thing. Apparently I had an invite, but I didn't notice because I was in the garden doing like weed whacking or something. Weeds. But the most important thing that were revealed is that, first of all, 3 engines that were out at the start, those were actually out before they even lifted off, and they decided to commit to the launch because that was within their launch criteria. They say that he said that there's no evidence that any of the rocket damage was due to debris. I think that's a hard one to prove one way or another. So not having evidence doesn't mean that it didn't happen. They said that they lost thrust vector control at about 85 seconds, and then that the automatic flight termination system did actually trigger, but it took 40 seconds from blowing holes in the tanks to the vehicle actually losing enough pressure to break up. And that was a theory that I posted about a day after the actual launch, a couple of days after the launch, and I had a lot of pushback on that, people not happy about it, but turns out that, yeah, I was right. Now, I was wrong about a bunch of other things, but hey, we're all speculating here. What he did say, though, is they're still confident with their 2-month turnaround on this. They're already filling in the hole, but I wouldn't be surprised if this is like Elon time on this. They're going to have their steel plate with water cooling on it. Let's hope it survives a little better than the concrete. There's also, in the wake of this launch, lots of clickbaity, hyperbolic news stories and statements on social media about Starship being grounded, and this is a conspiracy by the FAA and the government. Like, this is all to generate clicks. First of all, Starship is not grounded because it had a single launch license. It didn't have any future licenses for them to revoke. While they had plans and details about 3 flights, they had only been licensed for 1. Now, the FAA is absolutely going to want to make sure that they solve their problem with the flight termination system, and they may be interested to make sure that the debris situation doesn't happen again, but those are not massive problems, so I don't see that being a thing. This is not like some vast conspiracy, this is just due diligence, right? You want to make sure your rocket gets destroyed on time. One of the more interesting, by the way, pieces of post-flight analysis comes from the China Academy of Launch Vehicle Technology, CALT. And in recent weeks, they made so not only did they put this presentation out of what they thought went wrong, but they also have been putting out these presentations in recent weeks about their own plans for Long March 9, which is now looking a lot like Starship. It's going to be fully reusable in some model that'll have expendable options where it can put like 150 tons into orbit. It's going to have a whole ton of engines on that first stage. Yeah, it does look like they're doing what they do best and stealing some ideas or borrowing some ideas, being inspired. Right? The other piece of SpaceX news that's kind of cool is that they're taking over Slick 6 at Vandenberg. That used to be the Delta IV Heavy pad. Last Delta IV Heavy flew out of there last year. But now they're taking that over. It was originally built for the space shuttle, but of course it was never used by the space shuttle. The other piece of big news that we had been anticipating last week was Japanese Hakuto-R lander, trying to land on the moon. And it didn't go so well, unfortunately. It wasn't clear from the launch coverage, which just sort of showed them going to zero or close to zero and then going to simulation. But it sounds like what happened was the instrumentation on board wasn't sure how high up it was. It thought it was way lower than it was. So it planned to land at zero, and then it found out there was no surface there. And it kept descending at a slow rate until it ran out of propellant, fell the remaining distance and crashed into the surface. And now it's clear that it was using a number of different instruments. They had radio data from the Earth, they had inertial sensors on board, they also had a radar altimeter, but it's clear that they weren't using that as much as they should have, because otherwise they would have known how high they were. They did, however, get closer than India or Israel with their landers, so I'm sure they're going to be going again. It looks like they're planning on going again. So there's also this really cool photo that they posted from the orbit showing the Earth rising over the moon with a solar eclipse happening near Australia, which is pretty amazing. Now, while this landing was going on, being broadcast on the internet, I was also at Astra's Space Tech Day, since they're my local neighborhood rocket company. So I was sitting in the audience, trying to watch this thing and trying to watch the landing at the same time. Yeah, so Astra, while they didn't have a great year with their rocket launcher, they did use this money they raised from their public, listing, their SPAC, to acquire a company called Apollo Fusion. And they now actually have a pretty healthy business selling Hall effect thrusters in various forms. But yeah, after their bad year with the rocket launches and loss of missions, they've cancelled Rocket 3 and Rocket 4 is now the future. And they had an unveil of a Rocket 4. I'm not going to say mock-up, it's more a test article because they used the same manufacturing techniques to actually build up the tanks. So those are mostly consistent with what they have. They have the engines on it. So on the second stage, they announced that they were going to be working with Ursa Major for their Hadley engine. So they have that mated to the second stage. Apparently they were missing the roll control thrusters and the avionics on there. They also had some big windows cut in the interstage so I could actually look inside and take a look at this engine. I think that's the smallest closed staged combustion engine that's ever been made. On the back end of it, they had their two engines, which they haven't officially announced as what they are, but it's very obvious, given that I saw the word Reaver in a couple of places, that these are licensed copies of Firefly's Reaver engine. So they're building those in-house. Apparently they've made some modifications to make them work better for them. They hope to be able to launch this rocket for at least test flights before the end of the year, and they do have a contract with Space Force to launch a payload. It's a little bit bigger than Rocket 3, but it's still a pretty small launch vehicle. Now, speaking of small launch vehicles, Rocket Lab had an announcement of a new service called HASTE, Hypersonic Accelerator Suborbital Test. It's going to be using Electron rockets to launch hypersonic test payloads from wallops, right? And now, because it's not going to orbit, it can launch much heavier payloads, like 700 kilogram payloads. Also, as part of their other experiments related to reusability, they announced that they're going to be flying a reflown engine from a previous launch back in 2022. This is an engine on a rocket that landed in the ocean. They pulled it out the water, they took the engine, tore it down, rebuilt it, tested it, fired it, and so they're going to now put it on a rocket and see if they can demonstrate some level of reusability. And from small rockets to even smaller rockets. In California, Evolution Space announced that their rocket, the Gold Chain Cowboy, had reached space. They launched it from the Friends of Amateur Rocketry test facility in the Mojave Desert, and it reached an altitude of 125 kilometers. It reached over Mach 5. This is a 7-meter tall, 25 centimeter diameter rocket, and it's their first one to reach space, but their plan ultimately is to be able to launch payloads to orbit from this. They're just building up to it slowly, and that would be pretty amazing if they managed to scale that up, continuously from amateur scale to orbital scale. I'm here for you. In the last few weeks, AST Space Mobile demonstrated that they are now able to make phone calls from a standard mobile phone via their Blue Walker 3 satellite. So this was done in collaboration with AT&T. And to be clear, it's a long way from being able to make random phone calls with phones to satellites. I mean, beyond the fact that they only have one satellite and you have to be very close to it to actually make it work, the spectrum is not licensed anywhere in the world. AT&T would have to get modifications made to their license to allow them to use that spectrum for space-to-ground communication. Okay. For Europe, the Jupiter Icy Moons Explorer, it is mostly fine. It's headed out into deep space. It's doing its various checkouts. And unfortunately, they've discovered that the 16-meter long radar antenna for the Rhine payload is not deploying properly. So yeah, this is needed to perform subsurface radar sounding. And if they can't get it deployed, they may not be able to use that instrument at all. But other instruments are operating just fine, and that included a 10-meter long magnetometer boom that deployed fine. So yeah, that's unfortunate. They may be able to unhook it, they may be able to heat it, power cycle it, hammer it, bump it with the engines, but honestly, the history of solving these kind of problems is not hopeful. Generally, once it's out there, they can't do very much about it. Virgin Galactic, they got back to flying their Unity glider spacecraft with a gliding test dropped from their carrier vehicle. They're hoping to make powered flights again very soon and hopefully flying standard, paying passengers by the end of the year. That would be nice after all this time. Virgin Orbit, by the way, it's not dead yet. It's still in Chapter 11 bankruptcy. They hope to close the sale by the end of the month, but it has critically important staff on hand working on things, and they did deliver a final report on the failure of their UK launch earlier this year. They tested the filter, or they demonstrated the filter could have caused the problem. They developed a new filter. They showed that the new filter is going to hold in place. So they have a fix in place if whoever buys the company is interested in resuming launches. And if they will, they have a bunch of contracts already in place. But honestly, the prospects aren't great. By the way, meanwhile, Spaceport Cornwall, which was going to be their home base in the UK, it's actually expanded. It's got new space for new customers on hand, even if there's no guarantee of there being a launch capability on site anytime soon. And finally, Russia has confirmed that it is going to continue supporting the Russian segment of the International Space Station until 2028. And that's still a couple of years earlier than the US and other partners, but it does mean that we're guaranteed support for the next 5 years, which is a step forward, I guess. So yeah, that's the updates. We'll be back in another couple of weeks. Until then, I'm Scott Manley. Fly safe.